All right, so you guys know how to find the slope of lines. Today we're going to talk about finding the slope of a curve. So here I have a basic parabola, f of x equals x squared, centered at the vertex at the origin. I want to find the slope of this parabola. Okay, remember, slope measures how steep it is, how steep the curve is. So what do you think the slope of this parabola would be? Would it be positive or negative? So over here, would the slope be positive? Oh, it's going uphill, so it seems like it should be positive. But what about over here? Over here, it's going downhill, so shouldn't the slope be negative? Here, the slope is kind of flat, but up here it's really steep. So you can see that the slope changes all the time. It's different for different points on the curve. So what we're going to do today is we're going to find a way to sort of measure the slope over a certain interval. Okay, and that's called the average rate of change. So let's say that I want to find the average rate of change. So I'm going to abbreviate that ROC. So the average rate of change of f from x equals, let's say 3 to x equals 5. Okay, so I want to know how steep this slope is between x equals 3 and x equals 5. Okay, now during that whole interval, from this point to this point, the slope is changing. Down here, it's flatter than it is up here. Up here, it's steeper than it is down here. So it changes all the time. But we're going to find the average rate of change over that point. And here's what that's going to mean. So I'm going to take these 2 points, the one I get from plugging in 3 and the one I get from plugging in 5, and I'm going to find the slope of the line that goes through those 2 points. We know how to find the slope of a line, so we can find that slope through those 2 points. This dotted line that I've drawn is called a secant line. Okay, so I'm going to find the slope of the secant line. All right, so if you have 2 points, you know how to find the slope of a line. We have 2 points, so we can do that. All right, if this point is 3, if the x value is 3, what is this y value? Well, obviously that would be 9, because I just plugged 3 in there and get 9. Okay. If this point is 5, then this would be 25, because f of 5 is 25. So now I have these 2 points. I have 3, 9, and I've got 5, 25. I know how to find that slope. So that slope is y2 minus y1, so 25 minus 9 over 5 minus 3, x2 minus x1. 25 minus 9 is 16. 5 minus 3 is 2. So I get 8. So the average rate of change of that curve over that interval from 3 to 5 is 8. Now it's not always 8. And down here, the slope is probably less than 8. Up here is probably more than 8. Somewhere in between, the slope would be exactly 8. But the average rate of change of this curve over the interval from 3 to 5 would be 8, because that's the slope of the secant line between those 2 points. All right, let's work out a general formula for the average rate of change. So here's just some random function, f. All right, I want to find the average rate of change of this function over the interval from x1 to x2. Okay, so I want to go from x1 out to x2. And I want to find the average rate of change. So if this is x1, what would this y value be? So to find the y value, you just plug this number into x. So this would be f of x1. If this is x2, then this point would be f of x2. I'm going to draw the secant line. So there's my secant line. And I'm going to find the slope of that secant line. So the slope of the secant line is equal to y2 minus y1, or in this case, f of x2 minus f of x1 all over x2 minus x1. So there's a really simple formula for finding the average rate of change of the function. All it is the slope of a line. So there's nothing confusing about it. You've done it hundreds and hundreds of times. To get the y values for the slope of the line, all you have to do is plug in the x values to the function. That'll give you your two y's, you have your two x's, and you can find the slope. All right, so let's say I want to find the average rate of change of this function over the interval from 2 to 5. Okay, so I'm not going to graph this, I'm just going to use the formula. So our formula says that the average rate of change is going to equal f of x2, which in this case, let's call that 5. So f of 5 minus f of 2 all over 5 minus 2. So just y2 minus y1 over x2 minus x1. All I'm doing is finding the slope of a line. All right, let's work this out. I need to find f of 5. So let's put 5 into this function. All right, so if I put 5 in here, 5 cubed is 125 minus 5 squared is 25 plus 4 times 5 is 20 plus 1. So 125 minus 25, that's 100, 120, 121. 121 minus, now I have to find f of 2. So let's put 2 into the function. 2 to the third is 8 minus 2 squared is 4 plus 4 times 2 is 8 plus 1. So 8 minus 4 is 4, 4 plus 8 is 12, 12 plus 1 is 13. So 121 minus 13 all over 5 minus 2. All right, simplify that. 121 minus 13 would be 108 over 3. And will 3 go into 108 evenly? 5, 3, 9. Hey, it will. 36. So the slope of the secant line through those 2 points would be 36. So the average rate of change over the interval from 2 to 5 of that function would be 36. All right, recall that velocity is the change in position over the change in time. So here on this graph, I've graphed this equation for you here. On this graph, I have seconds on the horizontal axis and miles on the vertical axis. I have time here, position here. So if I found the slope of this curve, or the slope of a secant line here, I would have the change in y over the change in x. I would have the change in miles over the change in seconds. Or I would have the change in position over the change in time. Right? So again, let me say that. If I found the slope of this, that would be the change in y over the change in x. In this case, my y is position and my x is time. So if I found the slope, I would have change in position over change in time. That's exactly what velocity is. So to find velocity, I'm going to be wanting to find the slope of this position curve. All right, so let's think about this question. So after t seconds, a spaceship is this many miles from Earth. And again, I'll graph that for you here. So I plug seconds into this equation, and this equation spits out miles from Earth. So I want to find the average velocity. So I want to find velocity of the spaceship over that time interval. So velocity is change in position over change in time. So here, if I find change in position over change in time, I'm just finding the slope. So what I'm wanting to do here to find the average velocity is find the average slope or the average rate of change of this curve over this time interval. So from 3 to 5. So there's that point. There's this point. If this is 3, then this would be P of 3, which would be 2 to the third is 8 times 10 is 80. So that would be 80. If this is 5, then this point would be P of 5. 2 to the fifth is 32 times 10 is 320. Okay, so I'm going to find the slope of the secant line through those 2 points. So the average velocity is equal to the change in position over the change in time. So the change in position would be P of 5 minus P of 3. So that tells me my change in position over the change in time would be 5 minus 3, from 3 seconds to 5 seconds. This is miles. You've got to keep your units in here. This is seconds. All right, so P of 5 is 320 minus P of 3 is 80, and that's miles. Down here I have 5 minus 3. I simplify that. 320 minus 80 is 240 miles over 2 seconds. All right, and then reduce that. 240 divided by 2 is 120, and my units are miles per second, which is exactly what they should be for a velocity. So my average velocity over that time interval was 120 miles per second. Now keep in mind, the spaceship wasn't always going 120 miles per second. Here at 3 seconds, it was going slower than that. We don't know exactly how fast it was going. When you take calculus, you'll be able to figure that out, exactly how fast it was going. Here at 5, it was going faster than 120 miles per second. We don't know exactly how fast, but it's something faster than 120. But somewhere in between here, the spaceship was going 120 miles per second. All right, let's suppose we have this just random function f. All right, let's say that this is point x here. So if this is x, then of course this would be f of x. All right, let's scoot out just a little bit. So if this is x, let's move just a little bit forward. So let's make this be x plus some little bitty number. Let's call it h. All right. So pretend x was 5. And h was like 0.1. So this would be 5, and this would be 5 plus 0.1, or 5.1. So here would be 5, here would be 5.1. So h is usually some really tiny number. All right, if this is x plus h, then this would be f of x plus h. All right. Suppose I want to find the average rate of change of this function from x to x plus h. Okay, so I want the slope of this secant line. Okay, so you guys know how to do that. That would be f of x plus h minus f of x all over x plus h minus x. Okay, I can simplify this a little bit. Down here on the bottom, my x's will cancel. X minus x, those go away. And I'm just left with h. So I have f of x plus h minus f of x all over h. And this has a special name. This is called the difference quotient. This will have a very, very important use in calculus. Okay, so this is extremely important. This is called the difference quotient of a function. It's nothing scary. You know exactly what it is. All it is the average rate of change between x and x plus h. All right, let's simplify the difference quotient of this function. So DQ stands for difference quotient, not Dairy Queen. All right, so simplify the difference quotient of this function. So again, what is the difference quotient? Difference quotient is f of x plus h minus f of x all over h. So let's see if we can work this out. So first, I have f of x plus h. Okay, so what this means, f of anything means to plug that anything into the function. So for instance, if I said f of 5, you would put a 5 where the x is. If I said f of 7, you would put a 7 where the x is. If I said f of j, you would put a j where the x is. If I say f of x plus h, then you're going to put an x plus h where the x is. So let's do that really carefully. So I'm going to put an x plus h here. So that'll be x plus h squared minus, put an x plus h where that x is, x plus h. It's essential to have those parentheses around this x plus h. You've got to have those parentheses because you have to subtract all of this. And you still have a plus 3. All right, so this whole thing is f of x plus h. Again, all I did was plug x plus h into that function. So I'll put an x plus h here, x plus h squared minus x plus h plus 3. All right, now I have to fill in the rest of this. So now I have minus f of x. So I have to subtract this whole entire function. So minus x squared minus x plus 3. And I have to subtract all of it, so it's essential that I have parentheses around that. And that's all over h. All right, so here's the difference quotient. Now it's time to simplify all this mess. So let's do this really, really carefully. All right, I have to do x plus h squared. And remember, this does not mean x squared plus h squared. This means x plus h times x plus h, and you got to full it out. So if I do x plus h times x plus h and distribute it out, I get x squared plus 2xh plus h squared minus x and minus h plus 3. Now, this minus will apply to every term in here. So I'll have minus x squared plus x minus 3. And that's still all over h. All right, now let's simplify. I have an x squared minus x squared, so those cancel. Sorry about that. So my x squareds cancel out. And now I have, let's see, what else cancels? I have minus x plus x. Those go away. I have 3 minus 3. Those cancel. All right, let's see what I have left then. So I have 2xh plus h squared minus h, and that's it. Everything else is gone, right? Minus h squared, and 2xh. And it's still all over h. All right, notice that all three terms in the numerator all have an h, so I'm going to factor an h out of those. So I'm going to put an h on the outside. That'll leave me with 2x plus h minus 1 all over h. So double check that. If I distribute this h back, I would get 2xh, I would get h squared, and I would get minus h. And it's still all over h. Now, as long as h is not equal to 0, I can cancel these guys out, and my final answer will be 2x plus h minus 1, assuming that h is not equal to 0. If h was equal to 0, this one would be undefined. Can't have a 0 on the bottom. But actually, this one would be okay if h was 0. I would just get 2x minus 1. So if h were 0, these really wouldn't be the same. This one would be undefined. This one would just be 2x minus 1. So they would be different if h is 0. But as long as h is not equal to 0, these two guys are the same. And here is the simplified difference quotient of that function.